Hi, this is Sandy Chaika from Riverside Brookfield High School, just outside Chicago, Illinois, and I'm here to talk a little bit more about data abstraction. In this video, we're going to use lists as an abstraction to manage the complexity of a program and look at some of the exam reference sheet as well. So what will we learn? Well, for data abstraction, you will be able to develop data abstraction using lists to store multiple elements. We'll need to know that data abstraction provides a separation between the abstract properties of a data type and the concrete details of its representation. Data abstraction can be created using lists. We have an exam reference sheet which provides notation for lists, and we'll look at that in a moment. And on that sheet, you'll notice that the list index is going to start at 1 and go to the number of elements in the list. Any index smaller than 1 or bigger than the length of the list will cause an error message and will terminate your program. It's going to crash. So this is what your reference sheet looks like. If you forget about the indexing, because some programs index a little differently that you might use, remember that right under list operations, it reminds you that the index cannot be less than 1 or greater than the length of the list. Here we will always see both a text version of how to do something and a block version. They often look very similar. This particular information is telling us that if we put a variety of elements in a pair of square brackets and separate them by commas, we can assign them to a list. In this case, I'm assigning them to a list. In the block version, it looks almost the same, but the elements are in basically what looks like a rectangle. Sometimes I might make a list that has nothing in it to start with. I might have a new club and I am going to set a list up so when I have my first meeting, I can add members to that club. So I'll make an empty list. To make an empty list in text, I just make 2 square brackets with nothing in between and assign it to my list name. And block, it'll look like basically like a rectangle or a square. In this part, we will see that I can assign or copy all the elements from B list into A list. If anything's already in A list, it will replace it. It looks almost identical in the block. So let's look at some examples and ideas. So lists allow for data abstraction. We can bundle variables together. These variables could be strings, numbers, characters, anything you have. The nice thing is we will then have one name to a set of memory cells. I do not need to know how many variables will be needed. So if I have that idea of having a new club, I don't know how many students might show up for my meeting. So I don't have to figure out how many variables I need. I can make an empty list and then keep adding those students to that list. I don't really even need to know how the elements are stored together or how this list works. I just have to trust that it does work. So some examples from the reference sheet. And here I have a list called colors, and I've assigned to colors the variables red, blue, yellow, and green as one list. Here I'm doing the same thing in text form for a variable or a list called nums. I have 1, 2, 3, 4, 5, 6, 7, 8 numbers all being stored in this one variable as a list. Here is the exact same information in block form. Just to be clear, here's an example of making a list called names, maybe for my club members. And I don't have any members yet because we haven't had our first meeting. So this is setting it equal to an empty list. I'm setting an empty list, assigning it to names. Here it is in block form. Maybe I find out that I had all my lists in class B, all my students listed in class B, and now it turns out that they're all going to be in class A. Class A students are going somewhere else. So this will copy all my students from class B into class A and the block form of the same thing. So I'm going to let you practice a little bit. Taking a look at this question, pause your video, see if you can decide what the answer is. All right, hopefully you took a look at this. I have a list called scores one, and I can see some numbers have been assigned to it. I have a list called scores two, and some numbers have been assigned to that. Scores one now is going to have all the values from scores two assigned to it. So what's in scores one afterwards? Well, I'm not going to have the same thing as what I started with, so A can't be an option. I'm not adding the scores from scores two to scores one. So that's B or C are not right. Everything from scores two has been copied to scores one and replaced what was already there. So my answer here is D. Here's another example. Again, pause your video, take a look at it, and see if you can come up with the answer. All right, let's talk about this one now. So Sam and Ann are a list that have been assigned to A. Jamal and Tamara have been assigned to list B. Now here's what's going on. Everything from list A is copied in list B. At this point, Sam and Ann have replaced Jamal and Tamara. So they are no longer in list B. When I say copy list B back into list A, unfortunately, Jamal and Tamara are already gone. I already have Sam and Ann there. So I'm just replacing Sam and Ann back in there again. So this might not have been what you expected. This did not swap the elements. It actually replaced, and everything now has the names Sam and Ann in them. So what should you take away? Well, for data abstraction, we can develop this by using lists to store multiple elements. The abstraction provides a separation between the properties of the data type and the concrete details of its representation. We can do data abstraction by creating lists, and the exam reference sheet will give us some notation for lists. It also needs to be clear that our indexing according to the reference sheet will start at 1 and go to the length of the list, how many elements there are in the list. Anything outside that range will cause an error. Don't forget to look at your exam reference sheet. I'd really like you to become familiar with that before the AP exam in May. Thank you for watching this video. I hope you'll come back and watch some more CS Principal videos in the library. Until then, go out and have some fun with CS.